Alright, time for another DraftScience video presentation. So, this might be kind of a boring, uninteresting video. We're going to deal with the counter-argument in the only form they can put it in, which is gibberish math. And it's just gibberish. They're just playing little math trick games where they're basically breaking consistency and continuity. If they use their tricks consistently in other mathematical equations, they wouldn't get right answers. So it's just a contrivance to pretend they can undo the fact that they have no evidence. So for 300 years, they've been claiming this mv squared kind of energy. And let's understand, people claiming it back then were all religious kooks. Okay, so it's really a theology, a dogma, a religious dogma, that you must believe in this Holy Ghost of the kinetic energy. And it has no experimental reality. The fact is that you could take the idea of just make it metaphorical, a football player, and you're the quarterback. And there's things going to come that are going to try to sack you, okay? And I can put them in different configurations, right? I mean, I could have the worst case scenario where it's, well, it's not really the worst case scenario. I could have a 30-pound guy going, 100 miles an hour. Or I could have and I'm going to just get the same numbers each time depending on how I do this math. And I'll end up over here with a 100-pound guy. Then I just do that 30-pound guy going 100 miles an hour, a 100-pound guy going 30, and a 30-pound guy going 100. You can understand, like, I have a bunch of things in between, but basically it's all the same force. There isn't some idea that the smaller thing is more of a threat. Now, yeah, we can make it smaller and smaller and smaller, and I can make it so small that now it's a bullet, and it'll, go right through your hand. But you can sort of understand, yeah, it just went through my hand. It didn't knock me over. Okay, it went right through my hand. It made a hole in me. It can make a dent in me. It can affect me in different ways because I'm a physical object, and it can impose its force, by pushing into me, pushing into lots of parts of me. Or it can imply its force in just one little tiny area and be more damaging that way. So there's different ways the force can be applied to your physical form, but this doesn't have more energy. It can't do more work in the universe. It can't make more heat. It can't make more atoms move. It's just making a smaller number of atoms move more dramatically. And of course, the faster it's going, the faster it will cause its energy to be dissipated. It will release its energy quicker. Okay, but releasing it quicker doesn't make it more, and that's a critical thing. And so, yes, the karate guy can break a board with less energy, okay, by increasing velocity. By increasing the velocity, he can get through the board using less energy. But it doesn't mean that you change the basic understanding of the physics and understand that the pressure is still pressure. The fact is if you put the board under tension, there's going to be all kinds of little movements inside of the board. All of those count as work. And the work done is going to be the same, whether I break the board or I don't break the board. The same amount of molecular activity will be taking place. It's just that, yes, in one circumstance, you take advantage of the fact that the board has rules, magnetic rules about how the magnets inside are aligned. And if you hit them a certain way more efficiently, you can, transfer your energy into more of them because you don't waste a bunch of it on the first two, that kind of idea. So there's rules, but it's still the amount of atoms you can move, the amount of electrons, the amount of mass. And that's all you're doing with mass and velocity. So again, there's no evidence in the universe of mv squared. It can't point to me to any experiments that demonstrate this stuff happening, that there's any such idea that you square the velocity. And so instead of pointing to evidence, they just keep saying, we have a math trick, we have a math trick, we have a math trick. And that's all they keep saying. So they have no counter argument based on physics in terms of physical evidence. They only have an argument that we contrive some math and it's circular and convoluted enough that you won't really follow along, so you won't get that it doesn't work. Because you won't really use it in the real world. Alright, so we'll play this crap, but it's just crap. It's just an evasion of the real conversation. So, I mean, it's not a coincidence that Pyrrho is doing a little bit of physics in his video. Clearly he's doing it as a counter to my videos. But he doesn't have the guts to actually counter what I say and the arguments I've made. And instead he just keeps talking about his Holy Ghost. The Holy Ghost is special and we all love him and blah 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 blah. But he won't deal with the facts, which is there's no evidence of him. It doesn't make any sense. Even your own Bible can't justify his existence. It doesn't explain it at all. It's mush. Silly mush. Okay, so he's gonna might as well get to this part. So I could enlarge this. Unlike Pyrrho, see, he does all his important stuff in this little tiny box. Kind of irritating, actually, but whatever. So gravity, they say. Alright, so let's do with this. They have a measuring thing, joule. Okay, it doesn't mean anything, it's just another unit. Like a second and a minute. It could be something in between a second and a minute. So they decided, okay, 100 years ago they invented a new way to measure something. So instead of a calorie or some other form of energy, they invented a new form, another one. Useless really. And it really just is an apple, okay, one of Newton's little apples falling 1 meter, okay, and when it hits the ground, so this is 0.1 kilograms, falling 1 meter, when it hits the ground, that's a Newton of energy, right there's, a joule. So a joule is just 0.1 kilogram falling 1 meter. Or, okay, it's a kilogram, okay, falling 1/10 of a meter. Or you can convert it into lots of, scenarios, okay, and then you can figure out how much time it takes for it to fall 1/10 of a meter. But that's all a joule is. It's a real thing. It's a clap of the hands, so to speak. Would be about a comparable way to understand it. You clap your hands of medium aggressiveness, and that's a joule of energy. So all this meters squared, kilograms squared, all kinds of things squared all over the place. Take a pause to fix my throat. Alright, should be good enough. Anyway, alright, so gravity, they say 9.8 meters per second. Okay, so the second you could understand, 9.8 meters per second. Now the fact that it keeps happening, that is, every second you get 9.8 meters. They think that's a reason to put a square on here and say per second means per second squared. Now obviously it really doesn't, because it could only be 2 seconds. Or it could be 4 seconds. Why would I square the seconds? That doesn't make any sense. So obviously this notation is one of the tricks. Okay, is to say when I'm going to have a force applied every second, then all of a sudden I put this little square here and indicate it's per second, when no, it's not second squared, it's per second. That is how long you did the experiment. So it's completely a false notation. It just creates a false impression that you're squaring the seconds when you're absolutely not doing that. Alright, and then so the 9.8 meters, you're never traveling this speed except after 1 meter. So when you follow 1 meter, no matter who you are, what you are, an atom, an electron versus the $6 million man, doesn't matter what's dropping, it always drops at this rate. Okay, it's the rate of the force being applied, and after 1 meter you're traveling 9.8 meters per second. For that millisecond, right? For that one little moment, and you only traveled 5 meters. So you only traveled 5 meters, even though you're supposed to be going 9.8 meters per second. That's what the force is. Well, the force takes time to accelerate you, so you're not going 9.8 meters, right? You're going very slow here, a little faster, and then you get up to 9.8 meters per second. So for this 1 millisecond right here, you're going 9.8. Right after that, you're going 10 miles an hour. Right here, you're going 12. You're going 15. You're going 25. So as soon as you go past that 9.8, that first meter, then you're going to be in plus territory where your velocity is now accruing interest. So that's what it's really about. It's compound interest. So you could do the same thing by just understanding that my money could grow. Like I could have $10 in the bank, I get 10% interest. And I get 10% interest, and I get 10% interest on the original $10. But if I add the interest and compound the interest and get interest on my interest, that's the velocity scenario. So you're never going 9.8 meters per second. You're getting pushed at 9.8 meters per second constantly. And obviously 9.8 meters per second is not a very fast speed. So if you turn this into, real bowling ball kind of scenario, this is irrational. Okay, but forces aren't applied by things going 9.8 meters per second. Gravity is not moving 9.8 meters per second. It's not some slow stuff just falling. I mean, not that 9.8 meters is all that slow, but it's like 20 miles an hour. Okay, I mean, it's not very fast, 9.8 meters per second. So it's a pretty slow speed. And obviously, how could I get up to thousands of miles per second, or per minute, or per hour? How could I get up to really high speeds if this really slow force is pushing me, right? If I can only run 20 miles an hour, how could I push something 40 miles an hour, 60 or 90, and it's going faster and faster? So we're getting rid of atmospheric problems. And you can understand that without atmospheres, things go very fast, and they just keep going faster and faster and faster. So obviously the pushing force isn't made out of something going 9.8 meters per second. Gravity's going the speed of light, okay? It's going c. And it's just giving you a tiny portion of its potential energy. So it's just giving you this little 9.8 added. All right, so it's just giving you a little each second. It gives you a little of its speed of light. So it has an endless supply to push on things going faster and faster. Now, obviously, once you're going close to the speed of light, the force of gravity is going to have a hard time pushing you any faster. Okay, it's going to have a hard time adding to your velocity, because you'll be going the same speed. It's going to have a hard time finding atoms inside of you that are still lagging behind a little bit to push on. Okay, so once you're going the speed of light, that means all your little bits are going the speed of light, are close to it. And there's nothing lagging behind to push on anymore. So that's why there's a speed limit. Yeah, because the force does have a speed limit. So the point is that this language gets confusing because it says things like 9.8 meters per second when nothing's really traveling 9.8 meters per second. The force isn't moving that fast, and you won't be moving that fast except for one moment during the trip. So when you hit the 1 meter mark, that's how fast you're going. But all the rest of the time, you're going some other speed. Your velocity is something else. So that's a place where, it can cause confusion. I didn't understand it this clearly until, I went through this whole laborious process of being re-educated by trying to forget everything the institution has ever told me, okay, and starting over with what can be deduced from actual evidence instead of storytelling, the little fables they tell. Okay, so again, he won't link me to an experiment showing that it takes 4 times as much gasoline to go 60 miles an hour than it takes to go 30. He won't show us any experiment, that demonstrates that this kinetic energy thing, this squared velocity thing, is true. Because no experiment demonstrates it. All the experiments demonstrate conservation of momentum. They don't demonstrate conservation of kinetic energy. And again, I could play the Professor Lewin clips over and over again, but I won't do that.
Meters per second, right? Because time has the unit of seconds and distance has the units of meters.
So if you want to know the velocity something's growing, you say, what's the change in the distance, okay, over how much time? And that'll tell me how a rate of velocity, how many miles per hour is it going now? At this moment, if I just duplicate what it's doing, how far will it go? What can I expect if it's not going to change? And that's what it's going to tell you. And then he keeps putting it into these units instead of actual numbers. Like, these are actual numbers. These aren't percentages. These aren't fractions. They're real numbers of distance and real amounts of time. They're not fractions.
Should I go check my comments? No, I don't have time for that today. So now acceleration is the change in velocity over the change in time.
Right. So you're just saying you don't need the change in time. All you need is the change in velocity, okay, technically, because the change in velocity, say if you change, the one in the bottom is just to tell you if you want to break it to a rate, so the rate of your acceleration. So if your change in velocity is a rate, 3 miles an hour, it's not change in distance over change in time in the sense that you've already reduced it to 3 miles an hour. And now you're just going to say, well, it's 3 miles an hour over a distance of a certain amount of time, so how much is per second? How much how much did my total velocity change at a rate? So what's the rate of the change in my velocity? And that's what acceleration is. It's a rate number.
Okay, so the change in velocity, that's going to have the units meters per second, and time is going to be over seconds.
Right, so this is the trick. So now he's going to do some little cross multiplication, a little simple trick, but it's not really fair because he has units, 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 and then he's going to put something in that doesn't have units. So that's the bogus part. Okay, obviously it breaks the whole continuity if you have units, 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 and then you put in something that's fourth dimension. You know, something that breaks the rules.
Okay, and remember, seconds equals seconds over 1, just like 5 equals 5 over 1. You need to know.
Yeah, but that's because now you have a consistency in terms of the seconds. It's not 2 seconds over 1 second. You know, well, technically it is.
Know that because you're dividing a fraction, and so you do the same thing where you're going to have, this is s over 1 on the bottom, so you have.
So it should be s in seconds, 5 seconds over 1 second. So it should be 1 second, not just 1. 1 what? You're going to divide seconds by nothing, or 1 meter, 1 frog, 1 belly button. No, it has to be also 1 second. So that's where they cheat.
Have seconds, I mean, times 1 over s.
Right, so we have the 1, which is the only thing not with a unit specification. So we have meters, we have seconds, and we have blah, 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 no unit. So if he did it with a unit here, seconds, okay, then he'd end up with meters, seconds times seconds squared, right? And then he could just cross off the seconds and he'd be back to 1 second again. 1 unit of seconds. So, you know, little cheats.
Apply the top and the bottom and you get meters over seconds squared.
Right, which doesn't make any sense. Again, why would you square the seconds? I mean, again, it just doesn't make any sense. Why square the velocity? Why square any of those things? It just doesn't make any sense. It just breaks all rational continuity. And again, it's just because there's no units here. If you put the seconds here, right, it has to be over 1 second. Not 1 meter, not 1 house, not 1 cloud, not 1 dream catcher, you know, for the little wooies, not 1 Holy Ghost. No, it's a second. So and then you just fix this, right? Because then you have ms, and then you have s squared, and you just cross out the squared and cross out the s, and then you have meters over seconds again, which is rational.
Right. Now, when you have things multiplied by each other, like kilogram meter, what does that mean?
Yeah, it doesn't mean anything. It's absolute crap. Because it doesn't mean anything. Distance can't mean anything until you have time that it travels the distance. So yes, it can't mean anything.
Well, multiplying comes from this concept of squares, and if this is x and this is y, then the area is x times y, because you take this and you multiply it by that, and you basically are getting all the slices, right? So that's how multiplication.
Right, so that's a rate. Things happen at a rate, so there's a certain amount of it's going to happen that you could put inside of a volume, and you could break the volume into pieces. But that doesn't mean that you, like again, the two x and the y's are going to be different things. So they're not the same number you're multiplying. The seconds in this one fraction is a different measure of time than the one in the other fraction. So the fact is you're squaring a number that you can't square because they're really two components of time. The amount of time you measured your velocity using, and then the amount of time you're now going to measure your acceleration. You can't do that.
Works in general in physics as well. So if I have a kilogram, oh wait, is my thing? Yeah. If I have a kilogram and I'm multiplying it by a meter, what I'm saying is I took a kilogram and I moved it 1 meter. So, well, it could be part of another equation, right? Now, why do you have seconds squared on the bottom there? Well, because
so there's no reason to have second squares, just seconds, because you're just really measuring how long did it take you to move 1 kilogram 1 meter, and that's seconds. It's not seconds squared.
I took the seconds and they kept changing how long something took. So, for example,
so we're just back to it happens per second, and then they say because again like gravity, per second. So when you're really saying it's happening, and then it can happen a variable number of seconds, you can push. So you're pushing a certain rate per second, and then I can decide to endure a certain amount of those pushes. There's no reason to square it because I don't know how many of those pushes I'm going to endure. I could be 5, it could be 500. That number is not squareable because it's going to be a number that's going to depend completely on how long you were in the gravity, for example. You can't square the seconds and assume, well, what if it was 5 seconds for my velocity, it's 25 seconds for the total experiment. That's not true.
Since when something's falling, but something's being pushed by a force, it's going to go a certain velocity. So let's say it's like the 9.8 meters per second.
Right, but let's understand the difference between a force, okay, as a raw force, gravity. So it's the same thing. Like this is just. I would love for somebody to counter this argument with some kind of reasoning. All gravity is doing is giving you weight. Okay, so it pushes on you, and all it does is create a velocity, and the velocity is your weight. So yes, you don't look like you're plowing into the scale when you step on it, but the fact is that's what you're doing. You have a velocity. Your atoms have a velocity. They actually push on the scale. It's just weight, and I can do the weight in this direction. Okay, so I can and so the only difference between things we push this way and the fact that what gravity's doing is how the force is imposed on us. These pushing forces, if I push something this way, I push on its surface. Incredibly inefficient in getting the energy into the object because it can deform, it can do lots of things that will dull the ability to push it. Gravity, on the other hand, okay, when it's dropping in free space, I don't have to worry about rotation, I don't have to worry about friction, lots of things are eliminated. Now there's some air friction. But the point is that's all gravity's doing. It's just pushing it, except it's pushing it internally. It's pushing the electrons and the protons. It's pushing the little bits, so it's perfect in terms of how it pushes. It pushes this little piece just as much as it pushes this little piece. So they're moving the same exact speed. They're doing the same exact thing, so their relationship to each other doesn't change at all, so we don't feel a thing. Where here, the relationship between this atom and this atom, this relationship changes constantly. As I push, this one moves, this one doesn't move. Because it takes time for the stupid force to get through the thing, this pushing force. It has to go through the atoms. It's very uneven, distributed, so I feel lots of stuff. So the ground is actually doing this horizontal thing. It's following the regular mechanical rules when it pushes back. That's why you feel the ground pushing back. You don't feel the gravity pushing down. But it's just weight in the end. You land with a weight. Okay, if I jump up in the air and then jump on the scale will go flying in one direction. It's measuring my joules of energy. It's weighing me. All right, and that weight is my energy. And so I can have weight in this direction, I can have weight in this direction, I can have weight in any direction, and that's all I'm going to have. If I'm up in the air, an airplane, and somebody shoots a missile at me, it's the weight of the missile that's going to break through the airplane. It's the weight. It's always weight. It's always the pressure with which it's going some velocity, and your stuff isn't going that velocity. You're stationary relative to it, and you're going to push it with your weight. It's always just mass and velocity, which is just weight. There won't be any counter-argument.
Squared. That means after 1 second, the thing will be going 9.8 meters per second squared.
No, it won't be going per second squared. It will be going 9.8 meters per second. That will be its velocity. There will be no squaring of the velocity. The truth won't be that you should square the number. No, no, no. You'll just be going 9.8 meters per second after falling 1 meter. Everything goes 9.8 meters a second. That's its velocity after it falls 1 meter. But as soon as it goes 1 meter and 1 millimeter, it's now going to be going some other speed.
Meters per second. Right? Because it got per second, it gets that velocity. In the next second, it's going to get that again. So 19.6 meters per second at this point.
So the velocity will be, that's the amount of, that's what you're accruing because you're increasing your velocity. And so you'll travel more distance because you're going faster.
However, this is 1 second long, but it's actually a greater distance because this thing is going faster and faster and faster since the speed is changing.
Right. In the first meter, you didn't go 9.8 meters. You just went 4.8 meters. So you obviously, if you were to say what was your velocity was 4.8 meters per second. But the fact is that over the whole trip, but that's an average over the whole trip. The fact is at the end of the trip, you're going 9.8 meters after 1 meter. But at the beginning of the trip, you weren't going that fast. It took you a while to get going. So you can only do averages here.
If we were to look at a chart, you'd see the velocity is going up linearly with seconds.
Right, but it doesn't do that, so that's not correct.
But the distance,
your velocity will keep increasing. It's like your compound interest. You're going to get more and more and more velocity.
Distance isn't going up linearly because it's going faster and faster and faster. So as time goes, it goes up like a parabola.
Right, both your velocity and your distance. Both of them are increasing.
The distance. And that is this.
So that was another deception. To imply that your velocity stays 9.8 meters, no it doesn't. The velocity of the force is 9.8 meters, technically, in the sense that that's what it's pushing with. But that addition, again, is not its the actual speed of the gravity is much faster than 9.8 meters. It's only 9.8 meters worth of push. So it can push 1,000,000 meters per second, but it only gave you 9.8 because that's how much mass you had. Well, it doesn't matter how much mass. That's how much mass gravity on Earth gives. That's how much momentum it gives. No, that's how much velocity it gives. So out of the billions of its little soldiers going the speed of light, it only allows 1 or 2 of them to hit your mass and move all of your matter. And so that speed of light has to be spread over your entire number of people. So they all have to keep 10% and give 90% away and then keep 10. So they're just exchanging and you all end up with just 10% in the end. It's like $1 getting spread over 100 people, and each one has a penny.
Is the squared graph. So that's why. So
it's not a reason why. It's not an explanation. It's not anything. It's just bullshit.
I'm going to go on and decompose these. I've already done this in previous videos, but I'm going to start doing it in streams. And we can see how we get a number like this.
I don't know who he is, so that was an interesting reference. Let me play that again, but that was an interesting reference. Interesting concession to the bullshit that this crap is.
Streams. And we can see how we get a number like this.
No, I didn't go back far enough. Strange. I'll go back further.
Squared graph. So that's why. So I'm going to go on and decompose these. I've already done this in previous.
He's already done this. So who's the he? I wonder who the he is.
Videos, but I'm going to start doing it in streams. And we can see how we get a number like this. And why we also have things like, you know, the fact that, you know, F. I want that.
So again, you can't change. I mean, I've already done that so many times. The simplicity of Newton's argument, and they keep trying to pervert it into saying Newton believed in mv squared when, of course, he didn't. He overtly opposed it. It wasn't part of his physics in any way. All of his correct answers were not a derivative of believing that there was any velocity squared. It's just a perversion. An overt lie to say Descartes and Newton somehow believed in this bullshit. They didn't believe in the Holy Ghost. And their fundamental religion, if you want to call it that, didn't have any mechanism to make a Holy Ghost out of. There's nothing in Newton's mechanics that dictates the squaring of a velocity. Forget it. It doesn't happen.
I think.
It's just a lie.
That F can equal mass times acceleration, but that's all.
So again, it doesn't equal mass times acceleration. So that's not Newton's formula. Newton's formula is it really equals momentum divided by, if you want the force in units, have it in time. Divide it by time if you want units. If you want to know the rate at which the force is behaving. Obviously, rate was really important because Newton was talking about gravity, mostly. Okay? He didn't do a lot of talking about other stuff. So rate was important. But rate doesn't mean anything when a steel ball hits a steel ball. Rate is irrelevant. I mean, for all practical purposes, it's an instantaneous exchange. Time is just, who cares? Because it doesn't mean anything. The force doesn't lose any momentum as it passes from one object to the other. There's no delay in its progress. So why are we pretending time could be at all relevant? It can't be relevant because there's no time to even have in the equation. It's just an amount of force. It's transferred entirely to another object. There is no bullshit about an acceleration. It's mass times velocity. The velocity stays the same. The force transfers entirely. So this is their bullshit.
Also the same as the change in P. Is it just the change in P? No.
Yes, it's just the change in P. Yes, it is.
Of course, it's change in P over the change in time.
Right, and the change in time can be any unit you choose. It's not seconds. It's not minutes. It's not hours. It's anything you choose. So if you want to know the force per second, you put the number of seconds it took for the exchange. If you want to know in hours, then you put the number of hours into the exchange. But if you want to know what's the total, then you don't need the time at all. And it's just a 1 down there. The same little trick you pulled. Okay, you just put a 1 there because it doesn't mean anything. The real truth is the force will equal your change in your momentum, period. That's the total force equals the total change in your momentum. So if we just use the word T, force total, we can get rid of the fraction, and it's just change in momentum total. The end.
You know, these things can all equal. Delta P is, you know, a delta M times delta V. And again, why would you
Obviously, yes, you're not going to change the mass in most of these collisions.
have mass times the velocity? Because you're taking that mass and you're moving it through the velocity. When the velocity,
you can't create weight any other way. The only way you can have weight is you have to have motion. Your mass has no weight if it's not moving. And the only thing that gives your mass weight is movement. And the movement can be in gravity, or the movement can be because you kicked a soccer ball. The way you impose the force has different manifestations, but the rule that it's just about how fast is it going is your weight, is your pressure. You never change that. And that's the one you'll never show me an experiment where pressure or weight isn't a measure of energy. Because that's all there is. And there's no weight squared.
It's changing, or even if it's constant, they get multiplied together. That creates a unit representing those things joined together. And basically, to finish up for the day, I know I'm rushing through this, but it is a quick battle.
I don't know what battle there is here. Again, there's no counter argument to any of my arguments. Nothing. No explanation of how Leibniz wasn't a religious kook. No explanation how clay experiments are completely fudgeable. I mean, it's like the worst way to do any kind of qualitative empirical measurement. It's the worst ruler almost imaginable. Okay. And that's all you have in defense of this mush. Made up nonsense.
The point is, you basically, in physics,
archaic, dumb, religious theory.
You have three things. The things are mass, which you might think of as weight, which is different.
No, it's not weight until it has a velocity. That's the whole funny part of it, right? So when you give mass a velocity, then it has a weight, and then it has momentum. And weight and momentum are the same thing. We might as well just get rid of one of those words because we don't need both of them, because weight is momentum. Weight is momentum. I mean, come on. Where's the counter argument? Show me a weight that's not a momentum. Show me one.
You've got time.
Or show me a momentum that's not a weight.
Time. And you've got distance.
So yes, mass and distance are real things. Time is just a unit thing. So that's just for, how you want to calculate a rate. So if you don't care about rates, you don't need time.
Okay, and since this is 3D, that's also called space. Okay, and so yeah.
Obviously, it doesn't. None of these fundamental arguments over the elemental functions are being done in 3 dimensions, so it's totally irrelevant.
We'll use kilograms, but obviously it could be pounds. We'll use seconds, but obviously it could be years. We'll use meters, but obviously it could be feet. Right? Now, given that, you simply have your d, your t, and your m for mass, right? And your velocity is...
The velocity is, yes, you could just break the t and the d into velocity, and then you have v and m, and that's all you have. Velocity and mass is your weight.
Change in d over the change in t.
So that's okay. So that's the only thing he's written that's right so far.
Acceleration is the change in...
So acceleration, again, just a bogus word. Acceleration is a rate. It's a rate. Acceleration is not an amount. It's a rate.
V over the change in t, right? And then F, we introduce...
Right, so you already have something that's in time units, that is miles per hour, and you're going to divide it by time. Hours or minutes or seconds. So these 2 units are at cross purposes. So this is where the equation goes silly. It's not a change in your velocity. It's the total change. So you're saying, what was the total change in my velocity? It's not my velocity per second or per hour or per anything. It's just a change in your velocity. So you're taking a point where you have a change in the velocity. It could be this big a point, it could be that big a point, doesn't matter, but it's a specific place where you're saying, what's the change in my velocity? The rate of your acceleration is going to be that divided by a unit of time, like Newton, where he just said, pick a unit. So they're not the same.
Use m times a, right?
So he just keeps doing it. That's not what Newton wrote. So again, your whole concept of using acceleration as a real concept is sort of just bogus, because you don't need it. It's superfluous. Once you have the change in your velocity, now you're just saying, is it a change over a large unit of time? Then what was the incremental change in my velocity? So if I want to know per second or per hour, then I can use units. If I just want to know the total, what's the end result? The end result is this is the change in my velocity. There is no acceleration. There's just a total deceleration or a total increase in your speed. But that's all there is. It's not in a rate. So it's really important to understand that if you just put one of these letters here, F, well, do you mean F as a rate, or do you mean F as a total amount of energy? Which one are you using? The rate F or the total F? So that's where they create a dodge. That's where they find a loophole to keep changing when you're talking about a total amount of force versus a rate of force. And it's a big difference, and that's where they do the trick. That's where they put the joker in the deck.
And then in work, we take that.
Okay, so the work one is just completely bogus.
Force, and we apply it for a distance. Force times.
Obviously, it's force times time. So how long you're in the force, okay, decides how much work was done on you. How long you're in gravity, okay, where the gravity is affecting you, then gravity's working on you. Okay, it's about how much time. How far you travel, how fast you are already going, who cares? Doesn't mean anything. Gravity won't do more work or won't do less work depending on how fast you're already going. Gravity does the same amount of work. So that's where you can see a huge flaw in their logic. Okay, it should be force times time. The rate of force times how long you were exposed to that rate. The rate of gravity is 9.8 meters per second. How long were you in the gravity will tell you how much work was done on you and how much work you're going to be able to do on the ground when you hit it. Those things will be decided by time, not distance.
Distance means that I applied the force and I went a distance. So similarly.
And we know that that's completely dependent on how much friction you're going to incur. So how far you will go as a distance will completely depend on what I use to brake you. So what kind of mechanism I'm going to use to slow you down. Because we know that the distance is just going to be an expression of your velocity. How fast are you going, okay, when you went in? It's going to tell you how far you're going to go in distance. And so it's really just saying a velocity.
To that, momentum is F times time. Meaning, I apply.
Yeah, so exactly. And one of them's right and one of them's wrong. You want to know how a force affects something, you measure how long it's in the force. How long was the force being applied? How far you go is going to be completely dependent on how fast you were going before you even got there. Before the force even starts pushing you, you could have already been going 700 miles an hour. The force isn't going to do more or less work because you're already moving, especially things like gravity. It's going to apply its 9.8 meters per second. It's not going to apply anything more or less.
A force for 5 seconds. If I apply a force for 5 seconds, I will impart a particular amount of momentum. Oops, sorry.
Right answer.
MV. I meant to draw this originally as P.
Oh, so he's going to change it for no good reason. You had the right answer.
It's P equals F times time. And so you can see that because what does F equal again? It equals mass.
So it really is work. So let's just understand. And it's just force times time. How long were you in the gravity tells you how much gravity you collected. And based on how big your mass is. Mass is just the bucket you collect the gravity with. And you're in it a certain amount of time. And that'll tell you exactly how much work gravity did on you, and it'll tell you exactly how much you're going to weigh when you hit the ground.
At times velocity over time. I'm going to leave the deltas out. When you have to be careful and plug numbers in, that's when you really have to be that. Times T. So this part, that's F, and this is...
So again, he's made up a new F. So this is the mass times velocity divided by seconds, which doesn't make any sense at all. So yeah, I can't. What the hell is that shit?
The times t part. And as you can see, you've got an under t there and you got an over t. And so that...
Right, yeah, you have seconds and then you have t. So yeah, so he's just going to cancel them out and then I'm back to mv again. So what was that pile of nothing for? Oh, that's right, it was for nothing. Because we already know the answer is mv.
Equals mv. So force times time equals mv. Work equals force times distance. So that means if I apply a force...
So again, it just doesn't... The distance is just a measure of your velocity. How far you go is completely dependent on how fast you're going, period. So how's there any argument here? There can't be any argument. So if you understand your velocity is a fixed amount, then you're fine. But if you're going to change the velocity or something, I don't know. There's no excuse for squaring the velocity.
For a particular time, I impart a particular amount of momentum, regardless. If I...
An electron falling in gravity moves the same distance in the same amount of time. But they obviously don't have the same mass. The electron hits the ground with a completely different amount of weight than a human being would. So where's this make any sense? That you're going to measure how much work was done or how much work was done on the object by not considering how heavy it is. Because that's all that's going to matter. How much mass is it that you had to push? Now, if you're pushing them the same speed and one of them weighs a zillion times more, well, there's going to be a zillion times more force inside of that object.
Apply a force over a distance, then I apply energy, or work rather, which is energy. So this is how everything pieces together.
So did that all piece together for you? Did all that make any sense? You just proved the momentum formula. You didn't really prove the squaring of the work function by distance formula at all. So I don't know. You proved momentum works. Yes.
And really, once you get to energy, that's the most complicated sort of a unit decomposition that is required to start to understand everything about thermodynamics and all the...
Yeah, so you won't understand anything. You'll just get a lot of wrong answers. So, yes, sometimes it works out okay because as long as you have the same lie in your whole equation. So if you lie about what a joule is and you lie about how much weighs and all this other stuff, well, then you can subdivide it and it'll stay a little bit. It'll keep a little bit of continuity. You know, if you say a 4-pound pin going 20 miles an hour and you give it this fake number of joules of energy, okay, by doing its mass times its velocity squared, well, then you can say, yes, the bowling ball that made that happen, you can give it 500 joules of, you know, when it only had 50. You can exaggerate how much energy everything has, okay, as long as you keep it relatively consistent. But I've already pointed out the experiments that show where this breaks down. And you end up with free energy. You end up with a universe that creates perpetual motion. And we have no evidence that the universe does do that.
Accomplishments of 1,000 years of physics, arguably. So that is my contribution to the world. I wanted to get that before I went to bed. And
okay, so he's just reciting what Leibniz didn't even have, which was any math to justify his religion. So this didn't show up until the 1800s. Young, okay, was part of promoting the idea of the word energy and, you know, putting this into conventional physics in some sort of more real way like they've done. So the same guy who, you know, basically sold you a lemon in terms of the double slit experiment, his math didn't even work. Okay, his model didn't work. It's a fact. Didn't get right answers. Still doesn't get right answers. And this doesn't either.
And so, you know, I sort of did. I mean, I did, except for I think I started at 12:01, so it's tomorrow.
Yeah, well, whatever. Mush. I guess I won't bother playing the very end because he's done doing his the same argument over and over again. So he could have done the dot product argument, you know, that I pointed out, where they ended up multiplying the dot product as if it's not an indicator of direction, as an excuse to square the velocity. So these are all, they're just trying to contrive excuses to get velocity in there twice. to justify this much. And then the 1/2 just comes in, like in the gravity argument. In the first meter, the distance traveled isn't 9.8 meters. It's only 4.8 meters. That's where the half comes from. Do you think that's true when you're throwing a bowling ball? I mean, do you think that's true in all the other circumstances where forces are exchanged? I mean, gravity is, forces like magnetism and gravity, as stated, they're moving the entire molecular structure as a unit. They're not pushing on it. They're not pushing on a surface. Gravity isn't hitting my surface and then I have to make the gravity go through the rest of me, and so they're getting affected at different times. Gravity affects it all at the same time. Well, whatever. It's just pathetic. So they have no physical evidence, so all they can resort to is to say, look, the math god says so. And you can see where the math god has a lot of cheat in it. So just go back to the point where he had the fractions. And he decides to contrive a fraction. So a number that isn't a fraction, he's forcing it to be a fraction. And instead of dividing, creating a fraction that's the same units, that is, you have seconds divided by 1 second, he decides to just make it a 1. And that's a key point where if he did it fair, all right, then he wouldn't end up with seconds squared. All right. So I was going to do the Brozo comment page because they're playing the same game there, and they did link to a maybe I'll save him for tomorrow. The physics Dave or whatever the fuck he is, some Professor Dave. I think I responded to him a couple of years ago on the double slit thing, but yeah, it's some video on momentum and the conservation of momentum. And I don't know whether kinetic energy will get in that video. I haven't watched it all yet, so we'll see. Well, anyway, I'll save that for next time, I guess, unless something better comes along. I mean, it's just this counter argument is so bad and doesn't, again, evidence. You can't. 300 years they could come up with some experiment showing this kinetic energy thing, and in 300 years they have nothing. I mean, it's got to tell you something, that this is just desperate bullshit. Anyway, so till the next time and such. I mean, by evidence, I mean, measuring two things and pulling all of the energy out of them, all the heat they can create, all the everything. And you'll find out that the two things, like the bullet and the gun, which isn't a perfect example, frankly, just because the gun doesn't collect all the energy going the opposite way, right? The bullet goes this way, right, because of an explosion. Well, the gun doesn't collect its half of the explosion because a lot of the explosion leaves as gas. So some portion of the explosion the gun's going to permit to just leave. So the gun's only collecting some. And most of what it's collecting is based on the fact that, to shoot the bullet, you had to ignite the charge and blah, blah, blah. So the trigger and all that stuff. But if you had just a tube with a bullet in it and a charge and no stuff in the back, well, yeah, it's like a bazooka. It's still going to shoot damn good. It's still going to shoot. And the gun isn't going to collect much of the energy because it's really just collecting the energy that hits at these angles, right? The energy that goes straight from the explosion will not hit the gun. It'll just blow out the end of the gun. So the only energy that's really the gun's going to absorb is the little bits of perpendicular and tangential energy. So I'm just saying it's not really a perfect example in the sense that you have to make the gun collect its half of the energy. So you have a rod in the gun, and the rod collects all the energy. So you have a rod in one side, and you have a bullet in the other side. The bullet flies out, and the rod flies out with a weight on it. That would be the right way to do it in terms of making two things that are equally affected by the motion, equal and opposite reaction. Anyway, point is they've never done these experiments. So, I mean, come on. And why aren't they done? It's because they won't prove what they want to prove. It'll show exactly what I'm saying, which is all of this is crap. Silly crap. All right, what am I trying to do here? Oh yeah, the end. That's what I'm doing. All right, so till the next time and such. This has been a DraftScience video presentation to a dumb and stupid planet that wishes to remain belligerently stupid. Not stupid by accident, not stupid because they couldn't know better, not stupid for any good reason, stupid because they suck as people. Because they're intellectually dishonest, hypocritical, duplicitous, religious kooks defending mush for America. Waving of the flag. You're a great American, Pyrrho. A great lying sack of shit. A great traditionalist. Stuck in your myopic, stupid, and ignorant religion. Yeah. Okay. Now I'll leave. So fuck you, basically. Fuck you, fuck you, fuck you, fuck you. You're evil. Belligerently stupid is evil. So I could write that as a formula. Your evil quotient, okay, equals the rate at which you're being belligerently stupid. Stupid for no good reason. Stupid not because nobody told me better, nobody made a better argument, nobody, but no, they did do that. And you responded with nothing. I'm pleading. Show me your evidence or shut the fuck up, right? I mean, if you can't show a single piece of physical evidence, why do you have the right to argue your flat earth philosophy? Come on. No evidence and you can just say it? You could just draw your math and say, there's my evidence. I drew some math. Bullshit math, obviously. Alright, well, anyway. I just hate